टुडे जो हम क्वेश्चन करने जा रहे हैं ये छोटा सा क्वेश्चन है. इज अ क्वेश्चन ऑफ काइनेमेटिक्स. तो बिल्कुल इजी क्वेश्चन है. तो हमें बताया गया है पॉजिटिवली चार्ज पार्टिकल enters a uniform electric field and we have to calculate the direction of electric field with initial velocity to change the direction of the velocity vector by 30 degree in a minimum possible time. तो लेट्स ब्रेक इट. तो हमारे पास एक पार्टिकल दिया है which is moving with some initial velocity and is entering into an electric field. अब हमें क्वेश्चन बोलता है कि what should be the direction of electric field. What should be the direction of electric field so that if we want to change this direction of this velocity vector, initial velocity vector by 30 degree, that means by changing this vector to 30 degree, this will be our final velocity vector. So we have to find the direction of initial direction of electric field with the initial velocity vector, like here. So okay, our final velocity vector is moving at a 30 degree angle. This is what is our velocity vector should be the final velocity vector. That means, let us say we were moving initially like this and now we have reached up to this point. This is our final vector Vf. So this will be the change delta V. So you can say that Vf is Vi plus delta V, or delta V, this change in velocity vector is final velocity vector minus initial velocity vector. Okay, these are all vectors. Now, what is this delta V? We know that delta V is or we can say, let us see, small change in that, what is dV, which is AdT. Here, A is QE, let us say the charge Q and electric field strength is E divided by M. So because he's saying that electric field is uniform, that means its direction and magnitude is uniform. So A vector is uniform. That means in both magnitude and its direction is uniform. So its direction will be, so the direction of delta V or dV will be direction of A, and direction of A will be direction of E, right? So if this is delta V, it is equal to A, we can write it as delta T, because since A is uniform, so if we calculate this small dV, dV, which are all equal to AdT, because A is uniform, so we can calculate this delta V as simply A into delta T. Or if we want to calculate this length of this vector, is simply A into delta T. Now what we want, what is the question saying? That we have to change this direction. This is the change in direction. We can reach here also. We can reach up to this point also. This is also the same thing, because he's not talking about the magnitude. He's saying only change in direction. This can be our final velocity vector. This can be our final. We can reach through any numerous paths of this. But what he says that you have to reach to in a minimum possible time. That means we have to reach up to this point. We can reach, which is the shortest path. The shortest path is perpendicular to this from this point. So this angle is 90. So we can have now this is our final velocity vector, and this is our shortest path, which is 90 degree here. This is 30 degree. Okay, this was our initial velocity vector. This is our final velocity vector. This is delta v, which is equal to a delta t. Here, the direction of delta v is a, and direction of this is e. So this is the shortest path, we can say, and this will take the shortest time because the length of this is the shortest path. It depends on the time. So this is the length of this path will be the shortest path, gives us the shortest time. Okay, so this can be achieved when the direction of A is, what is it? It is, the direction of A is 120 degree with the initial vector, because, and that is the same, what is the direction of A is the direction of E. So we can say that E should be at 120 degree with initial velocity vector. Remember, it is not necessary that the final vector, the magnitude of final vector is equal to magnitude of initial vector. Because here you can see that this Vf is less than Vi, because the component of E is acting in this direction, which is reducing the velocity what was initially. Hope this you understand well.